So hi guys, today we are going to continue tutorial 7 with the exercises we didn't have time yesterday. So the first one is exercise 3. Exercise 3. Find the mean, median, and mode of the numbers. And we have 5, 5, 2, 3, 5, 6, 6, 4, 7. So we have these numbers. How do we calculate the mean?
Just add all of them.
Add all values and divided by the number of values.
Exactly. So we sum all of them and divide it by the number of elements we added. And then this is going to be 4.778. How do we find a median?
Teacher, the board is not that visible. I don't know, maybe the marker is light.
But it's a black marker. I don't know why. Is it still not visible?
Yes, it's visible.
Sorry?
Now it's more visible.
And
Yeah, it's better now.
or if I write here, maybe. I don't know. It's too small.
Yeah,
That's better.
fine. Yeah, this is fine now.
Okay. Okay. So how do you find the median?
N plus 1 divided by 2.
Sorry?
Like n plus 1 divided by 2, we add 1 to the number of elements divided by 2, and which gives the index of the sequence. And at that one.
For median,
Yeah.
Middle two numbers
we
you have
first
to
sort
add.
all the numbers and then take the central one.
Yes. So we write them in
Divided by
order, increasing
But we have to find the index of the central one first.
Yes, the central one. So which is the central one? So which is the median? This is 5, right?
But we have, Professor, we have the formula for finding the central index of the sequence.
Yeah, but the easiest for we have only these numbers. It's the easiest to write them in increasing number and pick the middle one. So from the
Okay.
smallest to the biggest, and then pick the middle one.
Mm-hmm.
And what is the mode?
Most occurring value.
Sorry?
Most occurring value in the sequence.
Yes. Yes, exactly. And which is that?
Which is 6 and 5. 5 and 6,
Yeah.
sorry.
The mode is 5. Yes. All right. We have done 4 and 5, which means we are going to do exercise 6.
Teacher, what if there's a value like what if 5 occurs 3 times and 6 also occurs 3 times?
Can we take the mean of the two?
For the mod.
For the mode, then we have 2 modes, I suppose.
Okay.
Yeah.
Okay, exercise 6. The intelligence quotient of 16 students from one area of a city showed a mean of 107 and a standard deviation of 10, while the IQs of 14 students from another area of the city showed a mean of 112 and a standard deviation of 8. Is there a significant difference between the IQs of the two groups at significance level of 0.05? So we have 2 groups of students and we have their IQs meaning the mean and the standard deviation. And the question is whether there is a significant difference between the IQs of the two groups at the significance level of 0.05. See, again, the significance level came up of 0.05. Okay, so one of the hypotheses, so the zero hypothesis, is the two means are equal. So mu1 equals mu2. And H1 is they are not equal. So what do we do here?
Can you please explain this again? I did not get that one.
So we have exercise 6. There are two groups of students, and each group has the mean of their IQs and their standard deviation. So the IQ, one of the groups is 107, and the IQ mean for the second group is 112. Let me write it down. So the mean of the IQs of the first group is mean 107. Okay, and the standard deviation is 10. And the sample size, that is the number of students, is 16. Whereas we have the second group where the mean is 112. The standard deviation is 8, right? And the sample size is 14 students. Okay, and the question is, so here we can see that the mean of the IQs is 107 and here 112. And we want, the question is whether this difference is significant at the 0.05 significance level or not. If it's not significant, then we can conclude that the two means are basically equal. So there is no significant difference in the mean of the IQs of the students. Okay, so we want to check whether the difference between the means of the IQs of the two students groups are significant or not. This is what we are going to investigate. What we need to do, calculate the t-value. T-value is calculated by, we take the means of the two groups, take that difference, divide by some sigma times square root of 1 over n1 plus 1 over n2, where the n's are the sample sizes of the student groups. Okay, so the difference of their means over sigma times square root of the reciprocal of the sample sizes, where the sigma equals.
What does this t stand for?
T, this is the t-test. This is what we need to calculate.
And how would we know that we have to, apply t-test for this problem or something?
Because when you want to, when we have two populations and you want to find out whether the difference of the means are significant or not. So if you want to see whether there is significant difference in the two populations, then we need to use this t-test. Okay, so we have two populations, group 1 and group 2. We have the mean for both of them, in this case for their IQs. And you want to conduct this investigation whether this difference in the IQs are significant or not. Then you have to use this t.
Okay, Professor.
So sigma equals n1 times s1 squared. So the population size times its standard deviation squared plus N2 times S2 squared over N1 plus N2 minus 2. So let's calculate the sigma. So the first sample size is 16 times the standard deviation is 10, so 10 squared, plus the second sample size is 14 times its standard deviation is 8, so 8 squared, over N1 plus N2, 16 plus 14 minus 2, and the entire thing is under square root. And it gives us 1.45. No, it's not, sorry. It gives us 9.44. Okay, we just substitute the given values. It's quite easy. Right, so now we have the sigma, 9.44. Now we can calculate the t value. Let me write this. So x1 minus x2 is 107 minus, basically doesn't matter which order, it's better to write so that it's positive. So we have then 112 minus 107. Sigma, we have just calculated, is 9.44 times square root of 1 over N1 is 1 over 16 plus 1 over N2 is 1 over 14. Okay, I just substituted the numbers and it gives us 1.45. Now, what shall we do with this information? We have this t value. T value equals 1.45. We need to find the t value online. Since we are at the 0.05 significance level, which means we want our t to be between minus 0.975 and plus t 0.975. Why is it 0.975? So we said we have a 0.05 significance level, and we are using a two-tiered test. That is, if we want to chop off the 0.05, that is a 5%, right? We chop off altogether 0.0025, not 0.0.
0.025.
0.025. So we want to be at this t value, which is 0.975 minus and plus 0.975. And we want our t value, which we have calculated, to be in between these two, which means we need to check what these two values are.
How do we know it's 0.975?
Because in the exercise said we are at the 0.05 significance level, which means we chop off 5%. 5% is 0.05 in decimals, but we are using a two-tier test, so this has to be divided by 2. That is what we get here and here. And 1 minus 0.025 is 0.975. Well, 1 is the area under the curve. Because if it's a probability, then the entire probability is 1. 1 take away 0.025 is 0.975. Do you understand this?
Yes.
Okay. So we need to check online what these two values are. And we get that this is minus 2.05 and this is 2.05 if the degree of freedom is 25. How do we calculate the degree of freedom? We take the sample size. The sample size is n1 plus n2 and take away 2.
How did you get the minus 2.05 and 2.05?
It's, we check online. You go online and get this detailed table and you write that you want, I mean, you check these two. If you write that the degree of freedom is n1 plus n2 minus 2, which is 16 plus 14 minus 2, which is 28. So you need to write the degree of freedom, which is 28, and then you check these two values on the table. And we get that minus t at 0.975 is minus 2.05, and plus t is 0.975 is plus 2.05. And if our t value, which is this, which is what we have calculated, if it's in between this range, so between these two numbers, then we don't reject the hypothesis, which means we don't reject that the means are equal.
Can you please explain the last part? So yeah, I was, writing down the question.
So we calculate the degree of freedom, which is 28, and we go online and write in the table XU, the DF, degree of freedom. You type. Sorry.
We have to check this value online on the table, the degree of freedom.
Yes, you go online, the XU, the DF, and you type 28 or whatever it is, depending on the exercise. And then you check these two numbers. It will be given for you that this is this is that. And all you have to do is to check whether your t value, which you have calculated, lies in between these two values, minus 2.05 and plus 2.05. So it's 2. It's going to be a 2. It's a 2.
So in the XU table, in the XU degree of freedom table, we have to see if the value of minus 2.05 and 2.05 lies between 1.45.
The t value we have calculated, which is 1.45. This is what we gained, right? This is what we have calculated the t value. Whether this lies in between these two values, minus 2.05 and plus 2.05. And we can see that it lies between them, right?
Yeah.
It's not outside, it's between them. In that case, we don't reject the hypothesis. And the hypothesis was that the means are equal. So there is no significant difference between the means at the 0.05 significance level.
But Professor, we have two hypotheses. Which one to keep and which one to discard?
The first, we keep the first, which means more precisely, we don't reject the first. We don't reject H0.
Why not H1?
Because this is our hypothesis. This is our hypothesis. This is what we wanted to decide whether to reject or not to reject. Okay, so this is our hypothesis, the H0. That is, the means are equal. Means are basically equal. There is not significant difference between the means. And since we found that our t value is in between those two values, we don't reject the hypothesis. So again, the exercise was, there were two groups, and you wanted to check whether there is a significant difference in their means or not. Or in other words, the difference in their means is significant or not at the 0.05 significant level. For this, we calculated the t-value, and when we got the t-value, we just had to check whether with this degree of freedom, it lies between these two values, which we can find online for the t-table. And since it lies in between these two numbers, we can say that we don't reject the hypothesis, which means we say the means, there is no significant difference between the means.
And for degree of freedom value, do we have to check online as well?
No, you have to calculate that, but you have to type it.
What? Type it?
Yeah, because the table will ask you DF. You have to type it. What degree of freedom you have? And you just type 28 or whatever number you have.
We have to type in on a calculator, online calculator, right? That's what you are trying to say?
Yeah, you go online, and then you have to find this table.
Okay.
Okay, now we are going to do exercise 8.
Specific website that offers this table, like the calculator.
Probably, but maybe I think he used lecture slides you can find. I think she provided.
Okay, great. I found
Check. Or I would just write in Google t-value or t-tail test or something like that. Okay, so exercise 8. Exercise 8. Which of the three Queck square distributions shown below has the larger degrees of freedom? How do you know? So we have so this is the first curve, and then we have something like this, and we have something like this. So this is the second, and this is the third. So the question is, which of the three, so we have these three curves, which of the three Queck square distributions shown below has the larger degrees of freedom? Which one has the larger degrees of freedom?
Well,
okay, so
just a guess.
what we know is, so this is the probability, and this is random variable. So what we know is that these Queck squared distributions are positively skewed. What does it mean? That it tends to be asymmetric and goes to the left. So like this one. So instead of being symmetrical, it's asymmetrical and shifted to the left like this. Okay, but then as the degree of freedom as the degree of freedom increasing, then the skewness decreases. So as the degree of freedom increases, so gets bigger, then the skewness gets smaller which means the curve becomes more symmetrical, So we can see that this curve is the most symmetrical, okay? It's not skewed, which means it has the larger degree of freedom. All right, so because this is the most symmetrical, or with otherwise the least skewed, okay, it's not shifted like this. Okay, as the degree of freedom increases, then the skewness decreases, which means the curve becomes more symmetrical. Right? And then let X be a square-squared random exercise 9. Let X be a square-squared random variable with 3 degrees of freedom. Compute the following probability. So the probability that X is between 0.35 and 6.25. Okay, how do we calculate these probabilities? It's like similarly when we did the definite integral, remember? So this probability equals the probability that X is less than or equal than 6.25 minus the probability when X smaller than or equal than 0.35. You remember what is the case? So if we have a curve, the probability, so if this area gives us the probability, in case this area under the curve gives us the probability, let's suppose we have 0.35 here and we have 6.25 here. And we want the area between these two values. So we only want this area. Okay, what can we do? Since if we calculate the integral in 6.25, that gives us what area? The entire area from here, all these, up to the end here, tier 0. From 0 tier 6.25, the entire area up to here. Okay, but we only want this area, which means we want to subtract this area. How do we find this area? This area is f of 0.25.
But X should be greater than 0.35.
Sorry?
X should be greater than or equal to 0.35 in this formula.
Okay, sorry, 3. Yes, it's 35. Yes, thanks. 35. 0.35. So f of 0.35 gives us this area. F of 6.25 gives us from here the entire area to tier 0, to the beginning of the curve. Which means to find only this area, we need to take f of 6.25, okay, and take away, subtract this small area, which is f of 0.35. Okay, that is why we have this formula.
But in formula, Professor, it should be X is greater than or equal to 0.35, right? Where you are subtracting the probability of 0.35.
Oh yeah, you mean here? Yes. Yeah. Sorry. Thank you. Thanks. So X
No.
Yeah. So X is smaller or equal than 6.25. but x is greater or equal than, oh no, wait a minute. No, here we want to be between, so we have to subtract this. So we want to subtract where it is smaller. So it is good, like this. Yeah, it is smaller. Okay, because to be in between, so as I said here, f of 6.25 gives us this entire area up to the 0. But we want only this area which is greater than 0.35 and smaller than 6.25, which means we have to subtract the area given by f of 0.35, so which is smaller than 0.35. This what we wanted to subtract, right? So we need to subtract this part, and this part corresponds to this axis, which is smaller than 0.35. And again, we can find these values from online Q-square distribution tables. So we found that this is 0.9 minus, and this is 0.05. That gives us 0.85.
How do we check the value 0.9 and 0.8?
We go online and we have a so-called Q-square distribution table, Q-squared distribution table. And then you find these values. How do you just Google it? Or I suppose he wrote these links. I mean, put the links on the lecture slides where you can find. I think she'll put some links to the lecture slides where you can find these tables. Right? But you understand the idea. It's the same thing as when we did the definite integration.
Yeah, but the questions are really confusing. Like we have, I get confused where we have to apply which technique.
Sorry?
I get confused where we have to apply which technique. I mean, they are really confusing exercises, I guess.
Okay, it depends on, so this, it is a probability square, it's in the question. It was in the question that it was a Q-squared random variable, right? So it was given that it's a Q-squared. That's why you need to find the Q-square distribution table.
So we will be given the technique name in the question, right?
Sorry?
So we will be given the technique name.
Yeah, it's in the question. Yes.
Okay, so in exams as well, we will given the name of the technique.
So it's given in the question. So from the question, you will know what to do.
So in exam as well,
yes,
you guys will,
absolutely, of course.
It
has to be given. Yes, it's in the question. If you read the question, you see that let x be a Q-squared random variable. So it's in the question. Okay, so you need to find the Q-square distribution table. Okay, we have covered all the questions. Any questions for about yesterday's questions, maybe? What we covered yesterday?
I think we did not do the question 7.
We did. But we can do it again. But we did.
Okay.
We did. Okay, so anything else? Okay, we stop recording.